Okay, looking at number 34, again we're continuing with this idea of rational expressions, and we've got a proportion here. And the easiest way to solve these guys, and when I say proportion, I mean we've got two fractions that are equal to each other. If that happens, then your go-to strategy should probably be to cross multiply. So if we grab one side of this, we'll have 6 and v squared minus 4 equal to, and we'll grab the other way, 6 and v plus 2. Now at this point we're going to have to do a little bit of distributing and see what we're left with here. So on this side, when I distribute, I'll get 6v squared minus 24. The 6 goes to both pieces of it. And over here we'll get 6v plus 12. Now what I want you to notice here is that we are going to be left with a quadratic, okay, something that has squares in it. And so our best strategy probably to solve this is going to be to get everything to one side equal to 0. That's kind of my go-to with quadratics. So I'm going to be minusing 6v from both sides, and I'm going to be minusing 12 from both sides. So that'll get everything off of the right side, and it will end up equaling 0. I'll have still 6v squared on the left, and minus 6v. And then when I combine the minus 24 and minus 12, I'll have minus 36. So then, again, you know, with quadratics, a good go-to strategy is to factor. One thing I'll notice is that all three of these have a 6 in common, so I'm going to factor it out. And when I do that, I'll be left with v squared minus v and minus 6. And at this point, I will factor further. It's much easier to factor when I take the 6 out first. I will have v minus 3, v plus 2. And that will give me potential solutions. V equals 3, because 3 would make this 0, or negative 2, because negative 2 would make that 0. Now, one thing that I have to be careful with, it says check for extraneous solutions. Now, with rational expressions, extraneous solutions would be things that make the denominator 0, because I can't divide by 0. That's not legal to do in mathematics. And what you'll notice is this negative 2, if we put a negative 2 right in there, that would make the denominator 0. It would also make the other denominator 0 too. So this one is extraneous. The only answer is 3. Okay, but again, you know, with this, it being an equation and being multiple choice, you could do some guessing and checking, but the thing that'll get you is those extraneous solutions, so you want to know what those are. Okay, 35 is also going to be a cross multiply problem. So we'll do this one a little faster now that we have the idea. We're going to do x plus 5 times x minus 7 on one side equals, and we'll cross multiply the other way, x minus 5 and x minus 3, like such. So we're going to have to do some FOIL here. Okay, so when we FOIL the left side together, we'll get x squared minus 2x minus 35, and you can verify that on your own. And over here, x squared minus 8x plus 15. Now this one looks really, really nasty, but the good news is the x squareds are going to cancel each other out. See, when I go minus x squared and minus x squared cancel. So I end up with a much simpler equation. So what I'll try to do is get the x's all on one side. So I think I'll add 2x and add 2x. You could do this the other way as well. And minus 15 and minus 15. I know I'm doing a lot of steps at once there, but let's see what happens. When I add the two x's, those go away. And when I do negative 35 and negative 15, I get negative 50. And over here, the 15's cancel, and I'll end up with negative 6x. So when I divide both sides by negative 6, I've got negative 50 divided by negative 6. I'll end up with x is 8.33 repeating. And again, once I cancel those x squareds out, I'm just solving it like a normal equation. I've got negative 2x minus 35 equals negative 8x plus 15, or sorry, positive 8x plus 15. That's just a simple algebra problem, and I know you can do it. All right, 36 is another subtraction problem, and again, we've got a subtraction problem. I almost wonder if this is supposed to be an equal sign here, right here, if that's supposed to be an equal sign. But if it's an equal sign, then we just need to cross multiply and solve. If it's a subtraction problem, and I guess let's treat it as a subtraction since that's what's written, we would need common denominators. So this guy has a 6x, this guy has a 3x. Well, I could make this denominator common simply by multiplying this fraction by 2. See, I could turn a 3x into a 6x. And if I did that, I would have 6x as my common denominator, and I have the first numerator, x plus 3, and I'm going to minus, well, don't forget, this is multiplied by 2, minus 4. Well, x plus 3 minus 4, I can't combine all of it, but I can combine a 3 and a negative 4. That would be x minus 1 over 6x, and that's how I would subtract them. We've already done a couple cross multiplies. We haven't done a subtract, so I'm not sure which that was supposed to be, but subtract works just fine. Okay, 37. This is an equation to solve. And what the easiest way, notice I can't just cross multiply because there's two fractions, they're not on opposite sides of the equal sign. The best way to approach a problem like this is to get the fractions to cancel. And the way you can get the fractions to cancel is to multiply through by the common denominator. So in this case, the common denominator, well, this denominator is x plus 4. So that would have to be part of the common denominator. Okay, x plus 4s will cancel with x plus 4s. And this denominator is an x plus 7. So that should be part of the common denominator as well. So I'm going to multiply everybody through by x plus 4, x plus 7. I'm going to multiply all the way through. I'm going to do it at the far right side. Don't have a ton of room here, but I'm going to do it here. X plus 7, x plus 4. And I'm going to do it here as well, but I don't have room to write it again. So when I do that, over here it's just going to be x plus 4, x plus 7. The other ones I'm going to get a cancellation. Like in this very first fraction, the x plus 4's cancel, so I just have x plus 7. Over here, the x plus 7's will cancel, and I'll just have x plus 4. So once I multiply through by the common denominator, all the fractions should cancel, and I'm just left with a single line that I have to solve. So I'm going to start to simplify. I'm going to start to distribute x squared plus 7x. I'm going to distribute x squared plus 4x. And over here, I'm going to have to play the FOIL game. So when I put all that together, I'm going to end up with x squared plus 11x plus 28. Okay, so really long equation. This one's a pretty challenging one, but what I'm going to start to do is combine some like terms here. X squared and x squared gives me 2x squared. 7x and 4x gives me 11x. That takes care of this side. And over here, x squared plus 11x plus 28. Now, again, I see that I've got a quadratic here, so I'm going to try to get everything together on one side. So I'm going to minus 11x, and I am going to minus 2x squared and minus 2x squared. I'm thinking this is going to be negative over here. Maybe I should have gotten everything over to the other side, but it'll still work. So once I do that, this will all be 0, and I'm going to have negative x squared, and the 11x's will cancel, and I'm going to have plus 28, like such. And this one, could be factored, but probably what I would do to solve it, actually now that I'm seeing this, is I might go ahead and add x squared back to both sides. Go ahead and add x squared to both sides so that x squared equals 28. Square root both sides, and x equals plus or minus the square root of 28. That was an unpleasant problem, unless I made a mistake somewhere. So again, multiple choice. You can always do some guessing and checking as well. Just make sure that you do check for extraneous solutions. Okay, and that is the end of the rational expression stuff. I'll tell you, that's going to be one of the tougher spots on the exam for you, so you're probably going to want to spend some study time on that if you want to get it. Now, we're going to move into conic sections. This is more recent, so it should seem a little bit easier to you. Find the focus of the parabola. Well, the standard equation of the parabola is y squared equals 4px, and p tells me about the focus. So, 14 is 4p. So 14 is 4p. I got to figure out what p is. I'm just going to divide both sides by 4. And it's going to be a decimal, but 14 divided by 4 is 3.5. So the focus of this parabola is going to have to do with this. Now, what I'm going to realize is that because it's y squared equals, this is a left-right parabola. So the focus is going to be right here at 3.5, comma 0. Okay, this number 39, again, we're talking conic sections, but we're getting into a graph of a conic section here. And, you can look at the standard form of the equation and check on the graph, but probably the best thing to do, it's already y equals, input it into your graphing calculator, check the table, look at the graph, and you're going to find that the answer should be letter D. 40 says, write the standard equation of the parabola if its vertex is 0, 0 and its focus is 0, 7. What you need to recognize is a focus of 0, 7 is up here, so it's an up parabola. That means I'm using the equation x squared equals 4py. Well, guess what? The focus is p, 7, right? So x squared equals 4 times 7y, or x squared equals 28y. Done. Done. And of course, the other thing too is if you have 4 to pick from, you can try them all out. Okay, 41 is also a real easy one. Write the standard form of the equation circle with radius 6. Well, the equation for the circle is x squared plus y squared equals r squared. Radius is 6, so x squared plus y squared equals 6 squared. Since 6 squared is 36, B is your answer.